Hi, welcome to video 8.2a, the introduction to integration by parts. So this is something new, which is good. Alright, here's the formula, which you will need to memorize. It is the integral of u dv equals uv minus the integral of v du. And you'll have to remember to ask me a neat way to remember this. But I won't say it in the video. So, what we're going to do is we're going to start with the fact of the product rule, okay? So we know that if we have some function u and some function v, and we want to take the derivative of that product, we take the first factor times the derivative of the second factor, which is d dx of v, plus the second factor, which is v, times the derivative of the first factor, which is d dx of u. So what we're going to do is, instead of writing du dx and dv dx, we're going to call it u prime and v prime. So here's what happens. Whoops. Okay. Alright, so on the left I have d dx of u times v, and I'm going to replace, as I said, the dv dx by v prime and the du dx by u prime. What then happens is I can get rid of the derivative on this side by taking the antiderivative of the right side. So now I end up with uv equals the integral of uv prime minus vu prime. And my bad, I should have a dx over there, because I also brought the dx over from over here. Okay. So now what's going to happen is you're going to have, I can break up the integral of a sum into the sum of the integrals. So I'm going to have the integral of uv prime plus the integral of vu prime. I am then going to isolate this term in the green box. So I'm going to take this term over here, send it to the other side. It'll be minus the integral of vu prime. And now I am going to rewrite that as the integral of u times dv dx. Instead of v prime, I'm going to go back to what we was before, equals uv minus the integral of v du dx. And that gives us our integration by parts formula. So what we do is we just say u dv equals uv minus the integral of v du. Okay, so what's going to be given to you is this original integral right here. Now, you're going to have to decide which part of that integral is u and which part of that, integrand is u and which part of that integrand is dv. The important thing is that you understand that the first thing you're going to have to pick is which part of it is going to be dv, because you will eventually have to integrate that dv to get the famous v here and here, and so it has to be something that can easily be integrated. And what you want is you want it to be the ugliest thing that can be easily integrated. So you're going to set it up as let u equal and let dv equal. But as I said, the first thing you're going to do is pick out your dv, which is the ugliest portion that is easily integrated. Once you've got that, then you come over here. The second thing you're going to do is let u equal the entire rest of the integrand. So let me give you an example. You see what we're talking about. So the bad news about integration by parts is it's not like you'll always be told, oh, integrate this by parts. You're just going to be asked to integrate. So you will have to know all the stuff from 8.1 and check for all the different things that we could have done from there, and eventually go, well, nothing else works. Let me try integration by parts. Okay, so here's an example. Your integrand is x cosine x dx. So of the two, I think we would agree cosine x is uglier than x, and I think we would agree that it is easy to integrate cosine x dx. So you're going to let dv equal the cosine x dx. You'll always put the dx part with the dv. The thing that's left after you pull out this cosine x dx right here, the thing that's left in the integrand is x. So we let u equal the remaining x. Now what you're going to do for this one, you're going to differentiate each side with respect to x. On this side, you're going to integrate each side. So I'm going to take d dx of each side. Basically, I get du dx equals 1, and then I bring the dx to the other side. So if u equals x, du equals dx. Over here, I want to isolate the v, so I'm going to integrate the right side. And of course, when you integrate cosine x dx, you get sine x. There will be no plus c here, okay, because this is just a stepping stone. We'll get to the plus c later. So here's the formula that we talked about for the integration by parts. It is uv minus the integral of v du. So you need u, which is here. You need v, which is here. You need v again, which is still here. And you need du, which you found right here. So we're just going to substitute that in. Our u is x, as you can see up here. Our v is sine x, so that becomes x times sine x minus the integral of v, which is sine x, times du, which is dx. And of course, I can now actually integrate sine x dx. So I have x sine x, which is what I have right here, and then the integral of sine x is negative cos x. The negative with the negative is positive. That's probably going to be one of your most common careless errors. And of course, don't forget the plus c. Okay, so there's the formula. Again, this is just me reiterating one more time. Let dv equal the ugliest factor that is easily integrated. Let u equal all of the rest. You can't leave pieces hanging around. Okay, so inverse tan of x dx. This is one of the more common ones because don't forget we know an integral that yields inverse tan, but we don't know how to take the integral of an inverse trig function. And that's a cue when you see an inverse trig function, most likely 99% of the time you're going to do it by parts. So we got to decide what to let u equal, what to let dv equal. Well, there's no point in letting dv equal inverse tan x because we know we can't integrate it. That's why we're using integration by parts. So we're going to let dv equal dx, that's all we got, and then we'll let u equal inverse tan x. So once we've got our u, we want to differentiate. So remember the derivative of inverse tan is 1 over 1 plus x squared. Remember we learned the integral of 1 over 1 plus x squared is inverse tan. That's because the derivative of inverse tan is 1 over 1 plus x squared. Over here we have dv equals dx. We want to isolate v, well therefore v equals x. So there's our u, there's our v, there's our du, here's our formula, and it's just a question of substituting at this point. So we're going to replace the u by inverse tan x. We're going to replace the v by x. We're going to replace the v by x, and we're going to replace the du by 1 over 1 plus x squared dx. So I'm just going to rearrange the order, make this look better. So I'm just going to move the x to the front, x inverse tan x. Now, here what happens is you actually can do this integral by substitution. Now notice I'm saying let w equals. I've already used u and v up here. I can't use them again. So I'm just picking another arbitrary letter. So I let w equal the denominator. And sure enough, if I let w equal 1 plus x squared, the derivative of that is 2x dx, and that's what I have. I have the x dx. All I need to do is introduce the 2, counteract with a half, and we are done. We have x inverse tan of x minus 1/2, and you're now integrating 1 over u du, which is the ln of the absolute value of u plus c. But of course, this quantity is always positive, so we do not need to put the absolute values. Okay, here's another example, x sine x, and I can tell you this very often when you have a product of a trig with basically a polynomial function, you'll probably do by parts. Nothing else will work, by the way. It's just kind of the only thing that'll work. So again, of the two, the ugliest thing is sine x. So you'll let dv equal sine x dx. Always put the dx with the dv. Whoops. Let me get rid of that. Okay, the thing that's left over after you use sine x dx is the x. So we're going to take the derivative of that. if u equals x, du equals dx, here we're going to integrate sine x dx to isolate our v. Our v will be negative cos x. So, the integral of x sine x dx equals uv minus the integral of v du. That's the integration by parts. We replace u by x, v by negative cos x, because there's our u, and here's our v, minus the integral of v, which is negative cos x, times du, which is dx. Now, can we integrate this? Yes, we can. We have negative x cos x. These two negatives make a positive, and of course you know how to integrate cos x dx. It is sine x plus c. Okay.